Welcome to Khetz and this is a continuation of the fundamental counting principle. Now, if you remember in the previous video, which I'll link on the top right, we basically talked about digits, and I did an example just to show how you use the fundamental counting principle. So I did say that if you have a 4-digit code and you have to fill that with, let's say, all the digits, which is 10, we have 10 digits, 0 to 9. And if you're not allowed to repeat any of the digits, in the first position, you have 10 options, and in the second, you have one less, and so on. So if you choose a digit, let's say you choose 6 out of the 10 options, 0 through 9, then let's say you choose 6, then 6 is out of the options that you can choose from, and that is why we're actually decrementing or taking 1 from the options. So whatever you choose is basically out of the options when you have to fill in the next space for your 4-digit code. Now there's a compact way of actually writing this, and that is the factorial notation. And the factorial of a natural number n is the product of the positive integers less than or equal to n. This is denoted as n factorial and is pronounced as, this should be pronounced n factorial, right? Pronounced. Okay. So the general form is this over here. So for example, if you have 6 factorial, then expect you have your n, which is 6, then n minus 1, which is 5, n minus 2, which is 4, then n minus 3, which is 3, and n minus all the values until you reach 1. So n minus the next one, which is 4, and minus 5 should be 1. So you stop here at 1. And this is 6 factorial, and you can see that this is in a way related to what I was doing with the digits. You basically have 1 less with each point that you fill up. And instead of writing it out in this form, this is a more compact form to write it. And an interesting thing to note is that 0 factorial is 1. Even though it doesn't necessarily follow this, 0 factorial is 1. And you do have the factorial symbol on your calculator. Just look out for that. And this is the factorial basically, and you can apply it just as you did previously, or just as I did in the previous video. And I have an example just to show how you'd use it, or how you basically apply all of this stuff to the fundamental counting principle. So the example says you have 2 different history books, you have 3 different geography books. This should be books. Once again, I have a typo over here. Should be books, and 2 different science books, right? And your task is basically to place them on a shelf. So in total, you have 2 plus 3 plus 2, which is 7. So you have one task, and if you remember the fundamental counting principle, if you want to do a certain task and you have m options and a second task where you have n options, then the total number of options, you basically multiply the 2. But in this case, we basically only have one task, right? And we have 7 options in that task, and we have 7 places. So imagine this is a shelf, and you can put one book here, another there, and until you reach 7, basically 1, 2, 3, 1, 2, 3, 7. So you can put any of the books in any of these positions, but since we only have 7 books to put on the shelf, then if you put one book here, you can't have it anywhere else because these books are different. As the question states, these books are different. So if you take any of the books, doesn't matter if it's a history book, a geography book, or science book, once you put it down, you can't have it anywhere else. So how do you show that? You can show that by writing the number of options that you have. So we have 7 options to start with. Any of the books can be in the first position. Then after that, you have 6 options because you would have taken one book, and you're going to continue just like that until you reach your final book, where you only have one option. So once you've exhausted all these books, or once you've placed these books, then you only have one option, in the end. And if you look at this, this is 7 factorial. So the answer to the first question, which says how many different ways can they be arranged, this is the answer, 7 factorial, because you basically have 7 options, one less option, just like that. So we have 7 books in total, and we're just basically trying to put them on the shelf, and the answer to the number of ways that you can have them arranged is 7 factorial. So the answer to the first question is 7 factorial. But now let's look at the second question. It's quite different from this one. It says, how many ways can they be arranged if the books of the same subject must be placed together? So let's say H for history, G for geography, and S for science. So we have 2 history books, we have 3 geography books, and we have 2 science books, right? So we're going to apply the same thing. Since we only have 2 books here, in the first position, we can put one or the other. But once we take one book, or once we put one book on the shelf, then we basically have one option left. And here we have 3 books in total, and we can put any of them. So we are basically writing down the number of options that we have after placing a book. So here, to start with, we have the total number of books to start with, because any of the books can start. But once we start with any book, we don't know which one we're going to start with. You have 2 options left. After those 2 options, you're going to place a book, which means you basically place 2 books and you have 1 left. And the same thing applies here. And all of these can be written in compact form. This is 2 factorial, and this is 3 factorial, and this is 2 factorial. And these are 3 different tasks that we have to do, that we have to look out for, and you basically multiply all our options, right? And after doing this, then we basically say that this is not the only order that you can have H, G, and S. You can say H, S, G, it doesn't matter, because you still have the geography books next to each other, you still have the science books next to each other, you still have history books next to each other, but it's a different order altogether. So how many different ways can you put H, S, G? And that is 3 different ways, which can be denoted by 3 factorial. So within the subjects, you have these options, but again, you can place the subjects in 3 different ways. And that is where that last 3 factorial comes from. So you first deal with the subjects themselves, or whatever groups that you have, and you check the number of options that you have. And since taking one option out of the total number of options will basically leave you with one less option, then you basically know that you have to deal with factorial. And the same applies everywhere. But since we're grouping this stuff, you can put it in any order, right? You can start with S, you can have it in, so there are 3 different ways that you can basically put these, and that'll be denoted by 3 factorial. So you can start with any of them, H, G, or S, but once you start with one, then you basically have one less option. Once you put another one, you basically have one less option. You basically multiply that, and you have 3 factorial options, or 3 factorial ways that you can actually order these. So you can move them around, and you can also move the books within each of the subjects. So this would be the answer that you basically get for your computation, or to answer the next question which we had in front of us. And what I was basically explaining was the reasoning behind everything that I did, and the answer would be 144. I basically shuffled around the H, G, and S, and within each of the subjects, we shuffled around the options. So with the factorial notation, just always think about options. How many options do I have? And am I actually decreasing the number of options after I do an action? So after placing a book, initially, for example, if we only talk about this point, initially we had 2 books, So to start with, I can start with any of the two books, which means I have two options. But after placing a book, which I have to do, then I have one less option. So that is how you deal with these kind of problems, or that is how you basically analyze the problems and then convert the problem into factorial notation. And you basically can find the answer from expanding these or from just putting this in your calculator. And in this case, our answer was 144. So that is all that I had to talk about with regards to factorial notation, and you can expand this to greater things as long as you understand what is actually happening, the options and everything that I basically explained. And I hope this was of value to you. If you like the video, just give it a thumbs up. And if you haven't subscribed, please subscribe, and I will see you in the next video.